Well, hello, this is, you'll have to excuse the shaky camera work and the fact my camera's a little broken, doesn't always focus properly. But yes, here's my 3D printer. I wouldn't recommend that you convert things the way I did. Now, what I did was I'd ended up removing the sort of daughter board here with where most of the connections were running to, and then running through that big ribbon cable right back down into the main board. I was lucky enough to have, family washing machine broke at the time, so this is literally composed of a lot of the wiring loom of said washing machine. Doing it this way, otherwise you're going to want to have a lot of copper, because what I'd essentially done is, find a good example here, you can pretty much see that I just, well, this one's actually been replaced a couple of times because it's the, I think that's going to, oh yeah, the fan, which has had a few replacements. But yeah, as you probably see, I just cut it off at the fan, essentially soldered on a big midsection of, like a big middle section of wire from the cut all the way to essentially just before the board down in here, where it was, where I've used the original header, because I didn't have any of them around at the time, and like hell, I was going to wait to, for one of them to come in the mail. So, yeah, it is a little janky in that sense. So what I'd probably actually recommend you do when you're modifying one of these printers to take a big Tree Tech control board is you're probably going to want to take, your little splitter board here that's normally mounted up around here. You're going to want to probably just take that, grab some good old DuPont cables and, shove one in, and then go ahead and use your multimeter or whatever that you're using to just test exactly where each of these is running. Now I can tell you that pin that I've got it hooked into now runs to the second from the end here, which is, yes, it's quite simple. If you understand where everything's going, you could just run this into the inside and even pick up some of these male to female DuPont connectors, because then in theory you could just run a whole bunch of these from the various pins on here to wherever they needed to go on the board. And then honestly, I just, either bloody hot snot or epoxy all of that together so it's not going anywhere. I know it's janky, but it'll do the job. And then, yeah, that'd probably be a lot easier than what I did. Either way, either way will work. That's semantics, really. Now, the first thing you'll probably really want to go ahead and do is grab one of these. Now, this is just the wiring diagram from Big Tree Tech's GitHub. I'll link to that somewhere. So the description, probably just go check that. I'll put it there. But honestly, this is a bit daunting initially, but most of it is actually relatively straightforward when it comes to things like the stepper motors up here. I was essentially just looking up, okay, there's a bit of a pattern on each of the wires here leading out of the stepper, so I was just I was using that to identify which pin they belong to here. From memory, most of these didn't need modification. I essentially just did, as I said, I extended each of these cables very manually. Once they were extended, I essentially just plugged them into the board. Nothing really changed there. So that was fairly simple. With this board, you'll see it supports ZA and ZB. So if you're Z, you're up and down, you can have two steppers. In the case of our ANETs, you're not going to do that. You're just going to have ZA, so hence why I've crossed out ZB. Don't worry about that. I wouldn't trust all the notes that I've made on this page, because some of them are probably incorrect. I was learning at this point, so just, yeah, careful with that. But yes, for the most part, you just got to make sure you get power from your PSU, which will be 24 volts. Make sure you've got, red on the 24, black on the ground, nice and simple. When it comes to this is the connector from the heated bed. Now, I cut that thing. I can't remember what was positive, what was essentially signal, and what was ground. Like what color was what? I'll have a look at that in a moment. If I've got any insight on that, I'll insert it in here somewhere. Don't worry about that. And then this, of course, was the end 0 is basically hot end 0. So you're not going to have any more than just the one of them starting at 0, because that's all this board will support, and that's all your head's going to have. So don't stress about that. In this case, you probably see I cut the little connector off the end and shove those wires directly into the correct spot on the board here. People say you should put terminals on them. They're not wrong. I didn't. I wanted to get it fixed. Hasn't burnt the house down yet. Don't stress. So fan 2 and fan 0, fan 1. Now that is an interesting one. I'll get back to you in a sec as to which fan's which. Because one of them's a part cooling fan, the other's like just the case fan that comes on to keep the board cool. And then there's one of them that's not used. I can't remember which one's which, so I'll get back to you on that one. X stop is just of course the end stop switch over here for your X. Y stop is the stop at the back, which that cable always gets in the way of. There. And Z stop. In this case, I'm actually using BTT, and I kind of recommend that you do, honestly. Up to you. But yeah, I never did get the capacitive bed level sensor that mine came with working. In fact, for me, it was just never reliable, even with the original ANET board. Part of that might have been because I was quite an amateur. This was my first printer. But honestly, I think from memory, it was just unreliable. I don't have nice things to say about ANET. But yes. So I recommend with that, if you get a BTT, you'll just be able to essentially plug that right into the Z stop. And then there's the first 3 pins here, I believe, will essentially be where you plug the other cable from the BTT into. As for which direction that goes, if that's an issue, let me know. If you want to go down this path, I can tell you how I did that. I have to remember how I did a lot of this stuff. It was actually quite a while ago. Okay, so THB, some of the that'll be where these two were. The signal, so as it was the heat signal for the bed comes from the 2 middle pins, whereas the 2 V's, the 2 24 volts here and the 2 grounds are just bridged together and shoved into there. That powers it. So your ground and your signal wires for your heat will need to be spliced into THB, which is thermal bed. So that's important. These aren't polarized because it's essentially just a thermistor, it's a thermal resistor. So they can go either way around. They just need to go in here. Don't ask me why I put positive and negative on there. I suppose technically there is a positive and a negative, but I don't think it really mattered in this case. Maybe you should adhere to that anyway. But this certainly wasn't polarized at all because it's one of those little glass bead thermistors. This is the thermal sensor for hot end 0, the only one that we have. So that's the other component of the hot end that you'll need to. You should just be able to essentially plug one of these plugs right into the board for this. Nothing special there. TFT is one of the ones that you'll use for that 4-pin. Ignore the state of my screen and the alfoil on things, communication errors and the like. At some point I thought I was getting interference. Don't worry about that. That's another thing entirely. But yeah, this 4-pin cable here, that's where that'll seed into. And don't worry, I know I'm probably missing a lot in this. Just in tell, I'm just kind of recording this off the cuff. I'll honestly just say, give us a message and I'll record whatever else is needed or explain whatever else is needed. I don't know where you're sitting in as far as skill goes or familiarity with all of this sort of stuff. I will say this all looks very, I went in cold. I didn't really have a lot of knowledge of how 3D prints worked at all. I went in cold and got this done just fine. It looks daunting, but give it a bit of time and you're like, yeah, that goes there, that goes there. It's fairly intuitive after a while. The biggest thing with this diagram is just the fact that they'll call things, THB, or what does that mean? That sort of thing. It can be a bit confusing to start with, but don't worry, you'll get there. This big connector, it's kind of the source of my grief at the moment. Communication between two boards, you won't have a problem with that more than likely, don't stress. This here is your big old serial style cable that communicates another communication cable to your display. So yes, that's plug and play. But as you can see, you probably won't need to chop too many wires, especially if you just do things the cheaty DuPont cable way. I'm sure there's plenty more elegant ways that you can think of than this though, so each to their own. Now, one of the first modifications I actually did internally was drill a bunch of holes in the bottom and put this bit larger fan on. Makes a little bit less of a horrendous noise than the stock fan, and well, frankly, the stock fan had lubrication issues. It was bad out of the factory. Just another one of the many parts from this printer that was giving me issues. Easy fix though. So now, this is the control board at the moment. It's know that it's going to this cable management's going to offend a lot of people. All I can say is it's normally hidden, so that's good, right? Yeah. But basically, you'll see I just used when I was connecting my stuff up, I essentially just used a bunch of whatever connectors I had around. So this, for example, is, well, good old reset switch from the front of an old computer case. It's not actually a reset switch now. Can you believe that? Yeah, how about that? Better throw that back in. I don't know that I'd recommend doing this because on the rare occasionally like something in my printer starts acting a little bit weird and I'm like, oh yeah, the cable's fallen out again. Don't build things this way. I was lazy. This is silly. There. See if I can find the main heater wire for the printer. Right. Okay, I'll have a look at that later. But yeah, essentially, as you can see, all I was doing was, at this stage, I was essentially just splicing in the, splicing into the stock ANET headers here, and just, sort of extending them right up to the top, out the other side. So there's no special source here. Then I just printed a little bracket to keep it, keep it in place, keep it nice and sturdy. And this will look intimidating. It's mostly just because of my horrible mess of wires. It's actually not that bad. So if you want me to go more step by step through sort of wiring all of this, I could. As I said, it just really depends on how much help is really needed around this. Just let me know, I'm happy to give a few pointers here and there. As for firmware and that sort of stuff, which is your next big step here, also ignore this. I've got another power supply in here. I just ripped apart a a modem, the 12 volt supply from a modem that I'm using to power this little camera I've got here, so I can have a look at my prints remotely. And yes, I know I could have just used a webcam or something like that, but I had an old security camera from work I did for the local pub. So yep, if you've got it, you may as well, right? But yeah, as far as firmware goes, this is running fairly stock Marlin with a few alterations. You do need to tell this thing, as you'll see in like the comments of the Reddit post. If you go down a bit, you'll see me talking about essentially the whole reason I was having issues here was because well, the runout switches on this thing, as they are, these are essentially normally open, right? So when they're in this position, they're not connected. Now, that's what I expected out of most every switch, but of course you can have them be normally closed so that when they're just sitting idle like this, their circuit's complete, which is how Ender 3s come configured. So, of course, considering this is a drop-in board for the most part, generally for Ender 3s, yeah, of course, it's opposite to what it's expecting. I guess if you didn't want to make firmware errors, you didn't want to make firmware changes, you could always just replace the end stops if you wanted to. That being said, rebuilding firmware isn't too bad, and the basic guides will generally get you out of trouble as far as that goes. It looks intimidating, but it's not too bad. This being said, I'm happy to. I got a message from someone else on Reddit who wants some of the firmware I used for this, so I'm going to need to look back into that myself. Essentially, because I've got to remember how to do this myself. There are errors in my firmware that are minor, but I should really fix them because it's like I have to remember to mirror every print that I do because one of my axes is just backwards. You don't need to leave it like that. I really should have fixed that ages ago. But yeah. So I'll look into that, and if you need any help in that respect, I'm happy to give that too. Like, that's fine. Just give me a bit of time. I've got to figure that one out myself. Shouldn't be too bad. As far as like firmware for this TFT35 or whatever big tree tech display you end up using, yeah, this is like the way they've got this set up. These make your life so much easier when they work. Like, it's, yeah. You just, if you want to make any changes, there'll be a nice configuration.ini file, which you just edit, and, it's all nicely commented and notated, and then you just slot it into your SD card slot port, and your printer will just, this board here, this display board in particular, will just pick up all the settings and apply. Not that you even need to do that generally, because realistically the menu system on these is fairly intuitive and will allow you to change a lot of the settings that you need to. This has saved me from having to delve into changing firmware settings in configuration.h, which is, it's a bit annoying to have to do. So yeah, these are actually really good for that. Mine in particular is having some errors communicating with the main board, which is causing printing issues, but I think that's a bit of a me issue, so don't worry, you're probably not going to have issues with that, especially if you've got the latest revision of the screen or whatever, so yeah, it's probably not something that's going to happen. I will say, if you're stressed about wiring things wrong on this board, there are a few things you can wire wrong that'll blow the board up, like anything really, but admittedly, the fault that killed my old printer, a short between, let's see if we can actually see it here, not really, but a short between these wires on the heater and the little thermistor that sits up in the hot end. On the stock assembly that it shorted, that sent 24 volts right through the thermal sensor, essentially into the wrong spot on the old control board. This blew it up right away. Of course, ANET's not willing to refund that despite the fact that I hadn't touched the head. Yeah, that's a whole story. But with this, I had left the error in place unknowingly, and what this board did was simply just boot cycle to protect itself. It didn't cook it. I've miswired a few things on this board just out of impatience. Should test things with your meter just out of impatience, and I've never cooked it. They are pretty durable in that sense. I can respect them for that. It will shut itself down. It will protect itself. It's pretty good with that. Not like the ANET board, that will just die. It will just confidently die. So yeah. Yeah, just give us any messages if you need any help, and that's really just the end of the story. Probably missed some things here, but yeah. Just give us a message. Okay, so just a quick note here at the end. I'm just going to attach, in the description and in the comment that I'll send you a modified version of the diagram I was showing off before, so that should just make things a bit easier.